Okay, we are on section 8.5-1. Now we are graphing secant and cosecant graphs. So we already learned how to do the whole entire standard form of combining all of our different changes, where we had our amplitude, we had our period change, we had whether or not we're going left or right, and our horizontal translation, and then we had up and down, which is our vertical translation, right? So now we're going to take everything and now we are going to start graphing secant and cosecant graphs. So for the first part, we're going to start out with this table. We have a table of thetas of negative 2 pi, negative 3 pi over 2, negative pi over 2, and so forth. So we're going to first find sine of that theta. So sine of 2 pi is just 0. Oops. 0, we have sine of a negative 3 pi over 2, which is 1. Sine of a negative pi is 0. Sine of a negative pi over 2 is just a negative 1. Sine of 0 radians is 0. We have sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. Sine of 2 pi is 0. Sine of 5 pi divided by 2 is 1. 0, negative 1, and 0. I just took all those thetas and just plugged it into my sine function. Now we have cosecant. Now if we go back to last chapter, the trig ratio, or how we say cosecant, is just 1 over sine of theta. So I'm going to take all these values of sine of theta and just do 1 divided by that value. So I have 1 divided by 0, this is an undefined value. I have 1 divided by 1 is 1, undefined, negative 1, undefined, 1, undefined, negative 1, undefined, 1, undefined, negative 1, undefined. Alright, whenever we are graphing with cosecant and secant, whenever it has undefined, if we have an undefined value, this is just going to be an asymptote on our graph. And this word goes all the way back to algebra. So this is when we have a graph and we have a dotted line. This means that there are no points hitting this dotted line at all. That this graph has a boundary at whatever this value of x is. So that's what's happening here. We have an undefined value, so I'm going to have an asymptote at a negative 2 pi. I'm going to have one at a negative pi. I have one at 0, at pi, and so on, wherever it says undefined. Oh my goodness, I spelled that wrong. Whatever. Okay, so we can start and plot our points. So we're going to plot our thetas on our x-axis, so go ahead and start with that. We have a negative 2 pi, negative 3 pi over 2, negative pi. Go ahead and fill this out. Okay, for my x-axis, I'm just going to put 1 and a negative 1. And now we're just going to focus on cosecant of theta. So we're going to go ahead and graph these points. So again, wherever it has undefined, you're going to draw out an asymptote. So I'm going to do this in purple. Here's our first one. Negative 3 pi over 2, we're at 1. We have another asymptote. Negative pi over 2, we're going down to a negative 1. 0, we have another undefined value, so I'm going to have my asymptote and go ahead and graph out this graph. Okay, so I'm looking at this graph and it doesn't really look like anything is popping up. Like, it just looks like a bunch of dashed lines and some points. So whenever we're graphing cosecant, we're actually going to graph out our sine. Go ahead and graph out your sine graph. Now we already know that cosecant is just the inverse of sine. So these graphs are just the inverse graphs, or the inverted graph of your sine graph. So before I get into that, I'm going to just focus on one period. I'm going to focus from 0 to 2 pi. So that's right here, and I'm going to show you what I'm talking about. So there's our amped version of 0 radians to 2 pi. I'm just focusing on one period. I'm going to add more tick marks on my x-axis. I'm going to add more units. So I'm going to add a pi over 6 and a 5 pi over 6. Now if I did sine of a pi over 6 is 30 degrees on our unit circle, so the coordinates are root 3 over 2 and 1/2. So sine of pi over 6 is just 1/2. So I'm going to go ahead and graph that point. That makes sense. It's on our sine graph. Similarly, a 5 pi over 6, the sine of that would also be 1/2. Now if I did cosecant, so that is just whatever your sine value is, 1 divided by that sine value. So I have 1 divided by 1/2 for both of these values of pi over 6 and a 5 pi over 6. So 1 over 1/2, that's just going to turn to 2. So I will go ahead and graph these points. And I'm also going to have this point of a pi over 2 comma 1/2. Okay, now so I have these points. I'm going to go ahead and connect them with a line creating a parabola. And I'm going to do the exact same thing for down here at 3 pi over 2. So basically, we have our sine graph, but it's the reciprocal, meaning that we have cosecant. So it is the inverted graph. So this graph is just a parabola. Okay, it's showing that we are never going to hit the values of pi because we have this asymptote. We're going to get very, very close to pi, but we're actually never going to reach that boundary right there. So whenever we have cosecant of sine, or of theta, this is what our graph looks like. It's just these parabolas. And if I were to show you with a calculator, it's 1 over sine of x. This is what our graph looks like. So there's our period length right there. Again, we don't see the sine graph, right? Because the sine graph is actually not there. This is just cosecant of x. So this means that we can graph out our sine graph. We don't really need it, but we're showing you how we get from sine of x to cosecant of x. So that's all we're focusing on, is just the highlighted portions right here. That is our graph of cosecant. So in this case, there's no amplitude, right? We have those boundaries, so we're not ever going to reach 0 radians at all. Our period length is just 2 pi. Our domain, it looks like we have all real numbers, so I'm going to say all reals, except when we have 0, pi, 2 pi, whenever we have these asymptotes or these undefined values. So I'm going to say ... comma, pi times k, and this is where you're going to see the k is in the set of integers. So this k could be a negative 2 pi, yeah, cool, we have an asymptote, negative pi, there you go, pi, 0, pi, 2 pi, and so forth. All right, our range. We're going to go down to all the way to a negative infinity. And then we have this maximum value of a negative 1. And it's included. And then we're going to pick back up at 1 and go all the way to infinity. Again, in this case, we are just ignoring our sine graph. We're just focusing on my highlighted orange section. So there are going to be no x-intercepts. There's also going to be no y-intercepts as well. Our parabola never reaches to 0 radians on our y-intercept. And then our vertical asymptotes, it's just the same thing as our domain. It's whenever we have x is equal to pi times k, where k is in the set of integers. It's just our x equations for that one. So that's when we had 0, pi, and 2 pi in our one period of 2 pi. And that's it. That is our cosecant graph. Similarly, we have our secant graph. So again, I'm just going to focus on one period from 0 to 2 pi right here. Cosine of 0 is just 1. We have cosine of a pi over 2 is 0. Cosine of pi is a -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1. Now, just like cosecant, secant is just 1 over cosine of theta. So I have 1 divided by 1 is just 1. 1 divided by 0, undefined. We have a -1, undefined, and 1. So in this case, in this one period alone, we're just going to have 2 asymptotes and 3 in our last example. So there's 1 at pi over 2, and there's also 1 at 3 pi over 2. So go ahead and graph out these values. We have 0, pi over 2, pi, 3 pi over 2, and a 2 pi. I'm just now graphing these values right here, and then these new values of our secant graph. Put 1 and -1 on my y-axis. And go ahead and start graphing out your points. So at 0, we are at 1. At pi over 2, we are having our first asymptote. At pi, we're going down to a -1. 3 pi over 2, we have our second asymptote. And then at 2 pi, we're going back up to 1. Now again, it just looks like some dashed lines and some floating points. So go ahead and graph out your cosine graph. There's my cosine graph. And just like how we had the sine graph and the inverted graph, which was our cosecant, it's the same thing. We have our cosine graph, and it's just the inverted graph of cosine that will give us our secant graph. So I have this point right here, and I'm going to draw out my parabola, and similarly my parabola down there, and same thing for here. Now I'm only focusing on this one period length of 0 and 2 pi. If I were to continue on, obviously these parabolas would continue on like that, but we are only focusing on this one period, so this is what we look like. All right, again, there's no amplitude, right? We're always going to have a boundary, so it's not going to be touching that pi over 2 value. It's going to be very close, but it's not going to be touching that value right there. Our period length is still 2 pi. Our domain, we have all real numbers, so all reals, except when we have pi over 2 plus pi times k, where k is in the set of integers. Now this means we just have pi over 2, right? That's our first asymptote. If we added another pi, so we have pi over 2 plus pi times 1, that would give us 3 pi over 2, which we see the other asymptote. If I have pi over 2 plus 2 pi, that would give us 5 pi over 2, which would be our second or our third asymptote. So that makes sense. Again, our range, now we are only focusing on this highlighted portion, which is our new secant graph. Our range, we're still going to go down all the way to a -infinity, and we're going to have our maximum value of a -1. And then it's going to pick up again at 1 and go all the way to infinity. Again, we have no x-intercepts,